Hello, I'm Dr. Ajay Sharma, Department of Electronics and Communication Engineering, GEMS Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester for BTech 5th semester Electronics and Communication Engineering student is digital communication, and the topic that I discussed in this video lecture is mean, sometimes called as expectation. So mean oblique expectation and variance and covariance function. Actually, expectation, which is also called as mean, expectation is an important concept in probability theory. Is that of the expectation of a random variable. So we always take the expectation or the mean of a random variable, right? So mean or expectation is a part of probability theory, and this particular expectation mean come in the picture when your variable is random, right? To overcome this randomness, we always take its expectation or mean. So if your capital X is a random variable, the expected value of X or mean value of capital X is denoted by EX. E means expectation. E means expectation or mean of X. So EX represent expectation or mean of that random variable, right? Okay, try to understand certain points regarding expectation of it or mean. For example, for a data set, you have some data set. The data set that you record by taking the reading of this random variable X. So you have certain data set that comes from your random variable X. For a data set, the arithmetic mean, which is also called the expected value or average, is the central value of the discrete set of numbers, right? Especially the sum of the values divided by the number of values. This is the basic formula of mean that we familiar as far as mathematics is concerned. The arithmetic mean of a set of numbers, you have a set of values that is coming from random variable capital X. The values are, for example, x1, x2, x3, x4 up to xn, right? So this the mean of these x1, x2, xn is represented by EX. EX means expectation or mean of the random variable X, right? Now, actually in probability and statistics, the mean or expected value actually is a measure of the central tendency either of a probability distribution or of the random variable characterized by that distribution, right? For example, if you take the case in a in a discrete probability distribution of a random variable X, right? The mean is equal to the sum over every possible values weighted by the probability of that value. That is, it is computed by taking the product of each possible value of small x of capital X and its probability px. So if you multiply x1 by its probability px1 plus x2 multiplied by its probability px2 plus x3 multiplied by its probability px3 and so on, and then adding all these products together, then EX can be calculated. So EX is nothing but it is the summation of x into px, where x is x1, x2, x3, px is p1x, p2x, p3x and so on. So this is the formula of calculating the expected mean when you have your random variable is discrete in nature, right? And as far as if your for example, if your random variable is the value of random variable is infinite, then in that case we have to take the integration. We have to integrate the xpx rather than summation. Now, well, so arithmetic mean of the capital X that have values x1, x2, x3 up to xn, we have to use this by ex, right? So that is the meaning of this particular thing. Now, come to the now come to the probability distribution, mean of probability distribution. The mean of probability distribution is the arithmetic average value of a random variable having that distribution. Because distribution, we already familiar about that in previous video lectures. We go through this distribution concept also. So the mean is given by summation of x into px if your x is discrete in nature, and if it is continuous in nature, your random variable x, then it is x fx integration minus infinity to infinity. So this is the only change, summation to integration. Summation come in the picture when your random variable is discrete, and integration come in the picture when your random variable is continuous, as far as their mean or expectation is concerned. Now, so the variance after the expectation or the average value or the mean value of random variable, then you should also have a knowledge of variance. What is the variance of a random variable, right? Actually, the variance of a random variable x, capital X, having any value small x, denoted by Vx. Some books follows Vx or some books follows VAR variance, VAR in bracket capital X. So there are two ways to denote this variance of random variable x, either by Vx or VARX, right? So in probability theory and statistics, variance is the expectation of the squared deviation of a random variable from its mean value. So it measures how far a set of numbers are spread out from their average value. Mean if you have a distribution and if you have a mean value, then this variance describes how the random variable goes on left to the mean value or right to the mean value as far as the distribution is concerned. So variance has a central role in statistics, and so variance, you can say variance is an important tool in the probability. And the variance is and how you calculate variance. The variance is the square of the standard deviation, and sometimes variance is nothing but sometimes it is the second central moment of a distribution. Yeah, right. If you take second central moment of a random variable, then the expression that is coming out to be a variance. So variance sometimes defined as the second central moment of a distribution or a random variable, and the covariance of a random variable with itself, and it is often represented by sigma square. So sometimes this variance is also denoted by sigma square in some of the books, or sometimes variance of x. So there are three ways to denote this variance, either by Vx or Varx or sigma square, and also S square. Some books follow S square also. So the variance of a random variable x is the expected value of the squared deviation from the mean, right? As far as the mean is concerned, mean is also denoted by mu in some of the books instead of ex, right? So ex, mu, both have the same meaning. Now, so what is variance? Variance is, I once again repeat, variance of a random variable x is the expected value of the square deviation from the mean of x. Means e bracket x minus mu square bracket closed. So variance of x is nothing but is the expectation of x minus mu square, where mu is the mean. So the so the variance can also be thought of as an covariance of a random variable with itself. So sometimes variance of x is equal to covariance of x comma x. So the variance is also equivalent to the second cumulant of a probability distribution that generates x, right? So so in other words, we can say that the variance of x is equal to the mean of the square of x. Mean of, look at this expression, look at that expression. What is this? What is this? This is the variance of x, which is equal to the mean, of the square of x minus the square of the mean of x. Look at this equation. So this equation, this particular equation, can be used for computing variance, right? Now, if you again we just take the case of random variable, if your generator or if your random variable x is in discrete in nature with its probabilities, means if the various random variables are given x1, x2, x3, and their probabilities are also given p1, p2, p3, etc., then variance of x is the summation of, this is the case of discrete, summation of p into xi, p into x minus mu, right? Or sometimes summation of pi into xi square, where I is equal to 1 to n. 1 to n means 1, 2, 3 up to n. So the mean Ex is a measure of the central tendency of a random variable that we already discussed. The variance of x measures the expected value of the squared difference between the random variable and its mean. Thus, the variance Vx is a measure of the spread or variation of the possible value of x around the mean. So, variance just give you the idea that how your random variable is spread as far as the density or the area is concerned about its mean position, either left or right. So that is the basic meaning of a variance. So there is a a relationship between mean and variance. Thank you very much.